Hi guys, in this video we learn what is the transform. To draw some kind of interesting or complicated images, you must know how to use transform matrix. There are lots of transform matrix. So in this video we'll draw this kind of group of circles. I'm going to introduce how to draw this image in 3 different ways. This is the first way. So to draw a circle like that, so let's say this is the center. So this is axis, and this is y-axis. So this is axis x, this is axis y. So let's see the left image. So if you wanna know what is the point, where is this? What's the point here? And let's see this big red circle. The diameter, the radius for this circle is 1. So this length will be just 1, and no, 1, right? 1. So let's say this circle, this angle is called theta. So what is the sine theta? Sine theta will be, sine theta will be, yeah, this is sine theta. How to know that? So let's see this triangle. Let's see this angle should be theta. So let's see this length is A, this length is B, and this length is C. What is the sine theta? Will be A divided by C. This is sine theta. And what is the cosine theta? Cosine theta will be B divided by C, right? Oh, no. B divided by C, right? This is an introduction to the sine and cosine. But in this big red circles, this distance from the center to the point is just number 1, because this big circle's radius is 1. Then let's see this is A. No, let's say this is A, and let's say this is B for my explanation. So sine theta will be, right? Let's see, the sine theta will be, where's the A? So A divided by number 1, right? Because should be C, but this is number 1. So sine theta will be A, right? Which means the distance from here to here. So the y coordinate for this point is sine theta, right? That's the A, right? What am I saying? And cosine theta will be B divided by number 1, right? So which means this B. So this B from the center to here will be this one, right? Cosine theta. So if you know the angle from the x coordinate, you can know the x and y coordinate using sine and cosine. So x will be cosine theta, y will be sine theta. But in real case, sometimes the radius is not number 1. So let's say this L, the length from the center to the center of the circle is length L. So let's change the number 1 into L and number 1 into L. Then what is A? In this case, the A should be L times sine theta, right? B equal L times cosine theta. So this B should be L times cosine theta. So you can times the distance from the center, the distance from the center of coordinate, and the center of circles. So L times cosine theta will be B. Here, B coordinate. So, and L times sine theta will be A. This might be a little complicated to you, in case you don't know what is this cosine and sine theta. So let me explain once again with these pictures. So I'm gonna find this coordinate. So which means you have to know this point. Let's say this point is B, and let's say this point A. Right. And that angle from the x coordinate is called x theta. So then what is the B? So let's explain once again. So sine theta will be here, the distance from the center of coordinate to the center of circles. Let's say this is L, the length. Yeah. Then sine theta will be, this is A, right? This is A. Then A divided by L, right? So which means A equals L times sine theta. Which means if you know the distance from the center of coordinate and the angle theta, you can know the coordinate of y, right? That's why we need the sine and cosine. And what about cosine theta? Cosine theta will be B divided by L, which means B equals L times cosine theta. That's the point here. So what's the x and y? So this, I have to change A and B symbols. So this B is x, this A is y. That's kind of ridiculous. But the thing is, if you know the angle and the radius of the circle, you know the A and B numbers, coordinate numbers. I told you there are several ways, right? So this is the first way. So let's see let's see, this is center. I'm gonna draw the line here. So I'm gonna draw the here center, and this is right. So let's say this is center. So I will draw the black circle to white one. So in this direction. So let's draw this one. So if you want to draw this one, you have to know the x point and y point too, right? So what's the x? Let's say this is angle, as I told you. This is angle theta. So what's the x? So x should be this radius. This is radius, right? X should be radius times cosine theta, right? So in this case, the center should be 0, 0, right? So you have to add the center x. Because so in mathematics, the center is the center of the canvas. But in processing, the left top corner is the center, right? So this is 0, 0. But you have to translate from here to there by adding the center x. So let's see this statement. So x coordinate should be radius times cosine theta and plus center x. Y is similar. Y is radius times sine theta plus center y. So let's start. So I'm gonna draw in setup function. So I didn't use the draw function because I'm gonna just draw one time. So let's make the canvas 800 and 800. And then let's clear the background. Actually, you don't need that, but anyway. So let's clear the background into white. And let's use no stroke function. And I'm gonna make, as I told you, I'm gonna draw 3 different ways, right? So my circles number 1. This is the first one. So actually, I'm gonna make 2 more functions. So I will do these things later. This is my circles 3 and 2 and 3, right? So I'm gonna make my circles 1, this function 2. So after my 1, I'm gonna call my circles 1, right? So what do you have to do? You have to draw lots of circles, right? So as I told you, for what I'm gonna do is you have to draw the circle one circle by one circle, and you have to different angles, right? So you have to change the angles using for loop. So let's use the float variable angle as it will be initialized into 0, and angle should be 2 pi. 2 pi. This green variable is system variable which has the pi. So 2 pi is 2 times 3.14, right? 2 pi. This pi is same to the pi in mathematics. and angle will be added about 0.2 or 0.3, right? So 2 pi pi. So what is the pi? Pi is around 3.14, right? And let's see. In processing, we have several kind of symbols to use the pi. So pi or 2 pi, half pi, quarter pi. So 2 pi will be, so how to use that? So quarter pi, half pi, pi, 2 pi, right? So let's see the first one, the arc quarter pi will be, this is 2 pi will be the kind of this for center. So pi will be half circle. Half pi will be 90 degree. So quarter pi will be 45. So this is radian way to denote the angles. There are two ways, radian angle and degree angle, right? So maybe you are used to degree, 90 degree, 360 degree, but in mathematics, usually radian is preferred. So I'll come back here. So pi is about around 3.14. This is equal to 90 degree. So if you use 2 pi, this symbol is, pi is 180. So 2 pi means 360 degree. So I'm going to use this kind of radian way to denote the angle. So what do we have to do? And we have to find the center of x, the center of y of the small circle. Right? Let's declare a variable x. X will be, as I told you, radius. So what's the radius? So I'm gonna declare the radius variable. So this radius is for from here to here, right? Let's say. So the radius should be, this should be radius. I'm going to use this one. This will be radius. So for this circle, you have to find the x and y coordinate. So this x is this one, right? So this radius is this one. I'm going to delete that. Okay, let's go back to the code. So x will be radius times cosine angle. So you know this cosine function. So this cosine function needs the angle, but this should be radian. So we are using the radian angle, not degree, right? There, as I told you, there are two different ways. Or radian. So this function needs radian angle. So yeah, and then what you have to do before times the radius times cosine, you need to translate the center to the center of the canvas. So we are gonna use center x. So center x will be here. So as I told you, here is the center x. So we have to make another variable. Oh, before that, float radius will be around 300, and float center x will be width divided by 2. Let's make the center y 2. So float center y equal height divided by 2. Let's make the same thing once again. So let's get the float y. This should be center y. No, this should be plus, right? Sorry. And radius times sine angle. I think that's it. So we have got the x and y for the small circles. So we are gonna draw the ellipse x and y around 50-50. Right? So before drawing that, let's change the fill color to from black to white, right? So how to do this? So when the angle is 0, the color should be black, right? But the angle, the maximum angle will be 2 phi. 2 pi. So let's divide by the angle with 2 pi. This variable will be 0 to 1. Does that make sense? Then you can times 255 to get the white. So this number will be 0 to 255. Right? I think that's it. So let's run it. How to? Yeah, I need a semicolon here. I need a result. So let's see. This is the way. So this is the first way to draw this kind of circle of image. But to draw this, you have to get this one. So if this is the final goal, that'll be fine. But if you want to make a little complex one, it's really hard to get x and y coordinate. So I don't like this. I don't like this way. So that's the first way. Before going into the second way, we have to know what is a transform, as I told you in this video. Yeah, it might be a little difficult to you, but let's try to do it. So let's draw this kind of images. So this is a house. So to draw the house, you need one triangle and one rectangle. So let's try to just one house images. So I'm gonna make a function to draw these images. So let's draw this one. As I told you in the previous, I need only one function, the step function. I don't need a draw function too. So let's open the canvas into 800. I'm gonna call house1 function. That means I need the house1 function. So void 1. So to draw this house image, we need a triangle, right? So I'm gonna fill 0 for the top, and triangle should be, what is the first point? So the topmost point should be 50, 0, right? And left point should be 0, 50. And right top corner should be 150. So this is for triangle. So let's make the wall. Fill using gray color. I need a rect function. So the left top corner should be 0, 50, and the width height should be 100 and 100. So yeah, that's the that's for the house, right? So with these things, we need the house image. So that's it for the just one house image, but let's make 8 house together. So we need to call the house1 function using for loop, right? So let's use for int I equal 0 and I less than 8 and I plus plus. And inside the for loop, I'm gonna call house1. No, we have to use 8 different points, right? So for the house number 0, this point is the kind of starting point, right? So for the second thing, this point. So we need all different points. So we have to change the x coordinate. So we need a little different function. So let's make a house number 2. So let's copy this one to make the house number 2, but it has to have 2 coordinates, right? So I'm gonna use float x and float y, right? And I need x and y to here plus x for the x coordinate. So I need all. No, actually I don't need y, right? Anyway, so but yeah, hey, no, we need the y. So for the x coordinate, we need to plus x. For the y coordinate, we need plus y. So 50 plus y and 10 plus x, 10 plus y, and then we need this one too. So this plus x plus 0 should be x, right? So 50 plus y, 100 plus Oh, it's not easy way. Plus y. Is that right? Oh, no. This is width is height, so you don't have to. So this is house 2. So let's change the house 1 into 2, and we have to give x and y, right? How to do give it? So the y coordinate around 300, and x will be times 100, right? So I times 100 is for x, y for the y, let's give 300. So there's no error and warning, right? So let's run it. Oh, what did I do? Maybe I forgot something. Triangle. Let's see the triangle times y and y. Oh yeah, I have to add x here. That's my mistake. So see, you got the same result, right? But to do this, we have to do a lot of buggy jobs. Plus x plus y plus x plus y. That's not a good way. So I'm gonna tell you how to do this. So to do this, to do transform, you need to this kind of transform functions. There are several groups of that. So the first 5 function has the keywords matrix. So we'll see these things later. And some of them has x and or y or z, right? All these functions for 3D. So we don't need that because we are now on 2D dimension. So the rotate function, scale function, and translate function. Actually, this kind of translate and scale is for 2D and 3D too. But this rotation is only for 2D rotation. So we're now on 2D dimension, right? So we'll see how to rotate, how to scale, how to translate. The main thing is all this transform matrix for transform what? Transform what? Transform the coordinate. So if you translate something, so let's see, so this is canvas, right? So if you want to move this rectangle to here, you need to draw some different spot. But this translate matrix will translate the coordinate itself. So actually the center of the coordinate here, right? So to draw this thing, you need to translate the coordinate to here. So after translating the coordinate, this point will be origin of the new coordinate. It might be a little difficult. So when you draw this one, the origin was here, right? Let's change the color. The origin was here, right? So this thing's too. But to draw this is house, still the origin was here. So that's why we need add something, right? So we need this kind of bucket jobs. So if you want to draw this one, then let's move the coordinate here. So actually the origin was here, right? So let's move the origin of the coordinate into here, and then let's use the same function. So I'm gonna use the house1 function, but after transformation, right? So let's go to the code. Okay, so I'm gonna make void house number 3. It will has float x and float y parameter 2. But house3 function are gonna use house1 function, which means to draw the same house at a different point, we are gonna translate the coordinate system itself into x and y. After translating the coordinate, I'm gonna call house1 function, right? Without the parameters. I think that's it. And let's change this thing into house number 3. That's what I want. Right. Let's see what happened. Oh, that's a little weird. a little wheel, but we have two different houses. What am I doing? Let's see. So we are now calling the house number 3, right? House number 3. If you call house number 3, it translates X and Y. What am I doing? So which means if you translate somewhere, so let's say the first X should be 0. The first Y will be 300, right? Which means the translate function will translate the origin to the X and Y. So here is 0, 300. So actually the 0, 0, the left top corner of the canvas was origin, right? That was origin. But translate function translate to the center, to different point. So from now on, this is the center. So that's why we can draw just the first image. But the thing is, after moving to different point, this is new origin, right? So to draw the second image, you have to move a little bit right? So we need some more things. So after translate, we are going to use some other different translation or rotation. That's why we need to back up the current status, so current coordinate system. So we have to back up the current coordinate system before calling the translate function. That's why we need push matrix function. So this push matrix function will push the current matrix information for the coordinate system into stack, kind of. This kind of difficult, but so let's just remember to translate or before translating, so before rotating, before transformation, you need to back up the current status using push matrix. And after doing all the things, you need to pop. Push and pop will be the opposite, right? So pop the matrix information using pop matrix function. So the letter M should be capital. So before translating, you need to push matrix. After done all the things, you need to call pop matrix. Let's call this one. See? So using this kind of transformation, you can use this origin house1 function without modifying. So I didn't touch the house1 function, right? To draw the different point using translate. Yeah, that's why we need to learn the transform matrix. As I told you, there are several groups of functions. So all this thing is for matrix. So I have used push matrix and pop matrix here. So I have introduced you to translate. You can know the rotate, and you can use rotate and scale function soon. Okay, we can come back. So we are now drawing this kind of circles, right? Using kind of transformation. So we have done the first way without using transformation. So we'll make the second way to draw the circles. So let's go to the circle ways. So how to do this? We have to move the coordinate into here, because we are going to use the rotation here. So after moving the coordinate from the left top corner to here, you are gonna draw this. Oh no, you're gonna draw the circle in this way, in this sequence. So you are gonna draw this one first, and you're gonna rotate the coordinate. So if you rotate the coordinate, it will rotate the coordinate system into clockwise rotation. In Korean, 시계 방향으로. Yeah. So I'm gonna go to the code and let's translate function, where you need to translate the origin to the center of the canvas, right? So we are gonna translate with divided by 2, I divided by 2. That's the first one. So I'm gonna draw the circles using for int I equals 0. I'm gonna draw 20 circles around and I plus plus. So how to draw this? We have to rotate. So this rotate function means radian angle. So I'm gonna translate 20 degree. No, rotate. But this 20 is the degree. So you need this degree into radians using radians function. So you have to use S for the radians function. So this radian function will change the 20 degree into radians. So after rotating, so as I told you, this rotate function will rotate the axis. So let's say this is 20 degree. So by rotating the axis, you can draw this one at the same point. What this means? So after rotating, you can draw the ellipse at the same point. What do you mean? 300, 0. So after rotating, so this is new coordinate, right? You just still y with 0. So after rotating, y is still 0. So just draw this ellipse 300, 0. They'll draw this new circles. So let's go to the code, and the circle will be 50 radius. So, and let's change the color into 2 different ways. So let's just draw the black circles. So this is my circles 2. So let's go to the setup and let's call my circles 2 function, and let's run it. My circle 2, yeah, let's run it. See, so the field color is different, but we can still have the similar result. So let's compare circle 1 and circle 2. Which one will be easy? So the second one, right? That's why we need translate and rotate function. So let's use this kind of transformation matrix if you can. So from now, let's use the final thing, the final ways. So in this my circle 2 function, we didn't use push matrix and pop matrix. But without using that, if you draw some kind of complicated things, it'll be, yeah, difficult. So let's use the similar one, but use push and pop matrix. So first of all, translate to the same. And before, yeah, let's kind of, so in this case, we are going to use some different variable, angle. So we are gonna draw one circle and change into different angles, right? So the first one, the my circle 2 use the number of circles, but we are gonna use the angle variable in circle 3. So angle should be begin with 0, and angle is 2 pi, less than 2 pi. And angle will be added around 0.3. And before drawing something, let's push matrix and rotate angle. After that, we are gonna draw the ellipse at the same point, and then pop matrix. And I think that's it. So what is the difference? In my circle 2, they rotate 20, right? So after rotating 20, one more 20, one more 20, right? But here it will rotate the angle itself. So at first the angle should be 0. So it rotates 0. and then there will be pop matrix. It will go to the back or to the first status, and the angle should be added with 0.3. After that, it will rotate 0.3. So using push and pop matrix, if you pop matrix, it'll go back. It'll go to the first status. So let's go to the set function, and let's copy this one and to change 3. No. And let's run it. Oh, what am I missing? What am I missing? So I need the fill function. Before drawing ellipse, I'm going to use fill, but different colors. So this angle variable, if you divide angle by 2 pi, this number will have 0 to 1, right? So let's time 255. Yeah, like this. And let's run it. See, we have the same result. So let's compare all these ways. So the bicycle 1 use sine and cosine function to get the x and y coordinate onto this space, but I prefer the third way, the last way. So before doing some job, you have to transform, and before transform, you need to back up the current status. So the first one is push matrix, and the last one should be pop matrix. So that's the end of that. So in the next video, we're gonna use this kind of transformation matrix for doing some interesting things. Bye.